I'm just kidding.
I know.
This is my favorite class.
Thank you. I enjoy this class a lot, I have to say. I always look forward to my 8th period.
First period and last period.
On my desk. Somebody said a pencil?
It's quiet in first.
I keep running.
Oh my god, you went out.
All right, guys, here we go.
It's okay.
So, yesterday we reviewed slope. Hopefully you kind of remembered what it was already. But if you didn't, we reviewed that slope measures the steepness of a line by measuring the vertical change, the up and down, the rise, compared to the horizontal change, the run, right? So if you're going to look at slope or a straight line, the first question, take a warm up. The first question, a lot of people, Brendan, take a warm up. The first question says, does the slope of a straight line ever change? Will the rate of change, the slope, in between 2 points on a line ever be different? No, that's why lines are straight, because they have the exact same rate of change in between any 2 points that are on the line. This is why linear equations make straight lines. A linear equation only has one rate in its equation, so it'll be constant throughout the entire graph, all right? So it will never change. All right, then when we saw slope yesterday, you were asked to calculate slope 2 different ways. The first way was by looking at the line on a graph. The second way was by finding the slope of 2 points that make a line. I feel like this is a little bit easier, it's more visual, but guys, you already know, when you look at this line, should his slope be a positive number or a negative number? Based off what we learned yesterday. Is the slope of that line supposed to be positive or negative? How do you know it's negative? Because this is a what line? It's a falling line. It is going down from its left side to its right side. If the graph of the line slants in this direction, it always has a negative slope. And you should remember that because it'll help you when we get to graphing. So when you know that your slope is negative, that your line better look something like this. It better be a falling line. All right, so if you want to find the slope, pick any 2 points and let's count how we get from one point to the next. I strongly suggest that you pick consecutive points, like this point to this point, or this point to this point, or this one to this one, or this one to that one. If you pick these two, you will get the right answer because the slope is always going to be the same. The problem is if you don't pick consecutive points, then you're going to have to reduce at the end of your answer. If you're trying to avoid the reducing, I mean, if you can, sometimes you can't avoid it, but if you're trying to avoid reducing, then pick consecutive points. All right, I chose to go from this point to that point. So guys, if I have to get from this point to this point, his slope, his vertical change compared to his horizontal change, his rise over his run, do I have to go up or down to get to the next point? Down how many units? 4. If you go down 4, that's a negative number in math. So your rise, if you will, is -4. Over your run, do I have to go right or left to get to the next dot? Right, and how many spaces? 5. So when you go right in math, that's a positive movement. So that is +5. So the slope of this line is for every 4 units you drop down, you have to go to the right 5. And as long as you do that, down 4, right 5, down 4, right 5, you'll get from one dot to the next. And you'll make that perfectly straight line. So guys, if somebody chose these 2 dots, then they also would have gotten -4 over +5. It doesn't matter. All right, the only other thing I wanted to show though, because kids were asking me it in every class, is someone's like, well, I didn't do that, Hardy, I went up. That's fine. Guys, let's say you went from this dot to this dot. Now, do you have to go up or down to get to the next one? Up, how many? So up 4 is a positive number. Over, now this person has to go which way to get to the next dot? Left 5, which is -5. And guys, at the end of the day, that's the exact same answer. It doesn't matter who gets the negative sign. It's a -4/5. And technically, when we start graphing, you're going to have to use like both of those slopes to actually create its graph, okay? This slope gets you going in this direction, down 4, right 5, down 4, right 5. This slope gets you going in the other direction, up 4, left 5, up 4, left 5, but it's creating the same line. All right, perfect. All right, now we come over here. Now you have to find the slope of the line that connects these 2 points. So now they're not graphs. So now you're not allowed to count the spaces. You have to calculate the vertical change. You have to calculate the horizontal change. And how do we calculate change in math? What operation do you use? Adding, subtracting, multiplying, dividing? Subtraction. So now you want to subtract your y's and subtract your x's to find that change. All right, so let's do it. We're going to find change in y, our vertical change, over change in x. And again, I always feel like in Algebra 1, you're trained to go from this dot to this dot. So here we go. I'm going to take the second y coordinate, which is -4. I'm going to find the change. So what operation do we say? Minus. What's the first y coordinate? 2. Done. Over. Now let's find the change in our x coordinates. So now I'm going to start in the same order pair. I'm going to get my second x coordinate, which is 5, and I'm going to find the change, subtract. What's the first x coordinate? Beautiful. That turns to plus, and now you're going to get -6 over +8. So guys, that's the slope. It's saying for every 6 units that you drop down, you have to go to the right 8 spaces. Okay. Hold the phone though. At the end of the day, slope is a glorified fraction. It's a fractional comparison of the vertical movement to the horizontal movement. What do we always do with fractions? Reduce them. And what do 6 and 8 both divide by? 2, right? So we're going to divide them both by 2 and get -3/4. So the final, most simple version of the slope of this line is -3/4, which is saying for every 3 units that you drop down, you have to go to the right 4. So guys, in reality, -3/4, in a sense, is getting you from this dot to the next dot, down 3, right 4, on the correct line, that is. What the -6/8 is, it's probably getting you from this dot to maybe the one that's 2 away from him, but it's still creating the exact same line. So that's why you could say, wait a minute, how could down 6, right 8, and down 3 and right 4 get me the same line? Well, they're the same slope, except one of them is probably getting you a couple dots away from the first one, okay? All right, perfect. All right, so guys, yesterday I told you that slope questions come in 3 forms. A graph, where you count the spaces. Ordered pairs, where you calculate it using change in y over change in x. And then word problems was the third way they can give you that. Yes? Yeah. So the third way is word problems. So that's what I want to show you today. I want to show you the slope word problems. So I'm trying to get you into the right mindset when I ask you this last question. Guys, this one says, if Chris buys 7 apples for $21, what is the cost of 1 apple? I'm not saying you shouldn't know. It should be a pretty easy problem, hopefully. Does anybody know what 1 apple costs when you paid $21 for 7 of them? 3. How did you do that?
21 divided by 6.
Okay, you take the $21 that you spent and you divide it by the 7 apples that you bought. So 21 divided by 7 is $3 over 1 apple. So guys, these apples are selling at a rate of $3 per every 1 apple. So believe it or not, that is a rate of change. It is the rate at which these apples are being sold. So a lot of times you guys say, oh, Hardy, when am I ever going to use this? Guys, I'm not going to lie. As an Algebra 2 teacher, as a pre-calc teacher, a lot of you probably want nothing to do with math in your future and probably won't use a lot of the stuff that I am told to teach you. I will, but you will be a better student just for having seen it and learned it. You'll be more educated. But in reality, when it comes to like real world situations, slope is actually the one that you might have the most interaction with. How many of you could tell me roughly how fast your car was driving to school today? Did anybody drive? What did you drive? At what speed do you think, on average?
Like 35
Okay, 35 what?
miles per hour.
Ooh, 35 miles per hour, which means she's going to drive 35 miles per every 1 hour that she's in that car. That is a rate of change. That is a slope. How fast did you drive, Chris? Hopefully not too fast.
50.
50? That's too fast. 50 miles per hour, though. That is a rate of change. That is a slope. You drive 50 miles per every 1 hour that you are in that car. All right? That's an example. How many of you, if you're into cars, are looking at the details or the specifics of cars, and maybe you're thinking, man, my car just eats gas. I get about 12 miles to the gallon. Have you ever heard of that kind of expression? How many miles to the gallon you get? Guys, that's slope. That's a rate of change. It's how many miles you can drive your car per every 1 gallon. So slope actually has a lot of real world applications where you've probably seen it before. The rate at which things are selling, that's a slope, all right? So I'm gonna show you some word problems, and then this was my plan. I changed it after lunch. So my plan was to show you the word problems, and then on Monday, come in and start graphing lines. But then I realized, guys, next week is 2.5 days. We have Monday, Tuesday, and then a half day Wednesday, which I think makes our classes like 30 minutes, which is still a decent amount of time. But either way, so I think what I'm gonna do, being that we only have the 2.5 days, I don't wanna get like knee deep into graphing and then lose you for 4 days. I'm gonna give you a slope review on Monday, and then on Tuesday, you're gonna take just a quiz on slope. So hopefully it'll be another quick, easy quiz that we can start the second marking period off with. And then I'll figure out something to do on Wednesday, and then we'll go out for our 4-day break, okay? So that's what I'm thinking. Just slope, review on Monday, slope quiz Tuesday. All right, let's look at our notes and see these word problems then. Okay. Some of the word problems are definitely nicer than others, and you'll see what I mean. Okay, so we are learning slope, right? We saw that slope is just a way to find a rate of change between two quantities. We always tend to find it on graphs. We find the vertical change compared to the horizontal change, which ends up being the change in y over your change in x. What I always remember is your rise over your run. Okay, let's look at some word problems where you're finding a rate of change. This one? Oh, this one, sorry, I missed a switch it. Brendan, did you get one? Because I gave these out before. These are the notes over there. You okay? Yeah. All right, so I have a couple typos, but here we go. On Friday, you left for a weekend camping trip, it should say with 110 miles on the odometer and 14.5 gallons of gas in the tank of your car. So when you left, you had 110 miles on your odometer and you had 14.5 gallons of gas in your car. When you returned on Sunday, I don't know why I put that. When you returned on Sunday, the odometer then read 299 miles, and you had 7.5 gallons of gas in your tank. They want to know what is the fuel efficiency of your car. Okay. To me, this is one of the not so nice slope word problems because they didn't point blank say how they want your rate of change measured. So guys, you are literally talking about a change in the miles. That's one piece of information. And then you're talking about gallons of gas. So fuel efficiency, guys, do you want to talk about how many miles to the gallon you guess, or how many gallons to the miles? How does the saying go? Miles per gallon or gallons per mile? Miles per gallon. So that's what they want. They want you to measure this in miles per gallons. That's how we're going to set this up. And again, I feel like some problems will say exactly how they want the rate measured. They'll say miles per gallon in the problem. This one didn't do that. They are assuming that you understand that a car's fuel efficiency is how many miles per gallon he gets. All right, so we need to find the change in miles over the change in gallons. Okay, so guys, think of this change in miles as a y coordinate because it's always change in y on top, and think of the change in gallons as your x because you always do change in x on bottom. So sometimes, I didn't make you, sometimes they make you organize your information as an ordered pair. So if this is how we're going to calculate it, you would write the gallons as your x coordinate, and you would write the miles as your y coordinate. So when he had 14.5 gallons of gas, he had how many miles on his odometer? 110. So you could organize that as an ordered pair. And then when he had 7.5 gallons of gas in his car, the odometer said 299 miles. So again, I'm not going to make you do that. I do it just so you can see it organized like that. But sometimes it helps that if you give yourself some ordered pairs, then slope is even easier to find. Change in y over change in x. All right, here we go. Change in miles. But before I do it, this is where math can get a little neat. We are trying to find this car's fuel efficiency, meaning how many miles to the gallon does it get. But guys, is the gallons of gas in his car going up or down? It's going down. So technically, should this rate of change be a positive number or a negative number? If the change is going down, it should be negative. But guys, have you ever seen a car put on its advertising, hey, this bad boy gets negative 20 miles to the gallon? No. So we're going to get a negative answer because it's just how the slope works it out. But we're going to ignore the negative because of this real world application, okay? All right, here we go. So change in miles. We're going from 299, taking away the 110. Over the change in gallons, 7.5 minus 14.5. Okay, 299 minus 110 is 189, right? And then 7.5 minus 14.5, here's the negative, is negative 7. Okay, but we're going to ignore the negative. You don't always ignore the negative, but in this situation, this application, we don't want a negative fuel efficiency. All right, so guys, look at what it's saying. Right now, it is telling you that this rate of change is you get 189 miles per every 7 gallons of gas. But we don't want it measured like that. I want to know, well, how many miles am I getting per 1 gallon? So you always want your denominator to be 1. So guys, to get 1 as your denominator, divide these numbers so we can put that number over 1. So what's 189 divided by 7? 27, which is over 1. So guys, that means you are getting 27 miles per every 1 gallon. And that is your car's fuel efficiency. 27 miles per every 1 gallon.
So on test, we would leave it over 1.
Well, what I did it is I did it on Delta Math and I made the problem up. So the way I did it on Delta Math, and you don't have it tonight, you'll have it on Monday. I did a box that you're going to put 27 in. I filled in miles for you, and then it says per box, and I put gallon. So you would fill in 27 miles would be there, per would be there, you would put the 1. So this one should always be a 1. Okay? But yeah, that's how you're going to fill it in on your homework, but not tonight, Monday.
Like if it's on a test, you want 27 like over 1.
If somebody put this, like 27 miles per gallon, I get it. It's just I think I'm going to have you do it on Delta Math in both, so you're going to have to write this, okay? But I wouldn't mark 27 wrong.
He's asking if you put 1 over 27.
Oh, I'm sorry. Is that what you're asking?
No, like. So
if he didn't put the 1 there.
Yeah, so like if you just put 27 miles.
Then you're good. As long as you have it labeled miles per gallon, then I'll know the 1 is understood, okay? Just don't put 27 miles as the answer, because it's miles per, it's a rate, it's a miles per gallon. All right, let's try the next one. When you started your shift at work at 7 a.m., 120 steel valves had already been machined and were ready for assembly. At 3 o'clock p.m., your shift ended and 424 steel valves were now completed and ready for assembly. The production rate at your work is 36 steel valves per hour. Guys, read that again. The production rate that they hope you do is 36 steel valves per hour. So you're going to put who on top, valves, over who on bottom. Exactly. So this one is nice because they told you exactly how they want the rate measured. They want it measured in valves per hour. Okay, so they want to know what was the production rate for your shift and did you meet the target production rate? So guys, we're going to have to find the change in valves and then the change in hours. Now let me give you a hint. I don't want to say always, because always is a scary word in math, but 99% of the time, when they give you a time, like hours, or minutes, or seconds, or days, that's normally 99% of the time your denominator. That's usually always who you put on bottom. What are you doing per minute? What are you doing per hour? What are you doing per day? That's usually always your denominator when they give you some measurement of time. Okay, all right, well, if we do this, think of this as your y coordinate. and think of this as your x coordinate. So at 7 o'clock in the morning, you had 120 steel valves. And then at 3 o'clock in the afternoon, you had 424 steel valves. Just in case you want to see it organized as an ordered pair. Okay, change in valves. We're going 424 minus 120 over. Now here's the thing. I specifically put 7 o'clock and 3 o'clock as my x coordinate because I'm really afraid if I put 7 and 3 that you'll think, oh, it's 4 hours. Guys, how much time has gone by from 7 o'clock in the morning till 3 o'clock in the afternoon? 9 hours? That's 8 hours. That is 8 hours of time. 7 o'clock in the morning till noon is 5 hours. 7 to 12 is 5. And then 12 to 3 is 3 more hours. That is 8 hours of time. So technically, 3 o'clock take away 7 o'clock is 8 hours of time. So just be careful with time. It's not as easy as, oh, it's 4. I mean, sometimes it is. All right, if we had 5 o'clock in the afternoon to 7 o'clock at night, that's 2 hours. It's 7 minus 5. But not when you got noon involved, okay? All right, here we go. So 424 minus 120 is what? 304?
Yeah.
Okay, over 8. So guys, look what it's saying. Right now, you are producing 304 steel valves per every 8 hours. But we don't want to measure it like that. I want to know, well, how many valves per 1 hour are you making? So divide them so you can get a number and put it over 1. So what's 304 divided by 8? 38 over 1. So guys, you are producing 38 valves per every 1 hour. So what was the target production rate? 36 valves per hour. How many did they make? 38. So that's great. Did they meet the production rate? Yeah, they not only met it, they exceeded it. They made more than they had to. Okay? All right, perfect. Do we feel okay? You should have seen some type of version of this in, question?
Can I use that?
Yeah, in Algebra 1. So I don't know if it's ringing any bells, but you basically are talking about two things that are changing, and you're going to find the change in one of them over the change in the other one. Who goes where depends on what the problem says. All right, look at number 3. All right, it says a scuba diver is 30 feet below the surface of the water 10 seconds after he enters it. And then he's 100 feet below the surface after 40 seconds of entering the water. What is the scuba diver's rate of change? Well, guys, look at the two things they're comparing. We have how many feet into the water he was, 30 and 100, and then we have his time, seconds and seconds. So think about it. When you measure someone's speed, think about miles per hour, because I know you all know that one. Miles is his distance, and hours is his time. So now this guy's, his distance is measured in feet, and his time is measured in seconds. So would you want to rate this as he's traveling so many feet per second, like miles per hour, or would you want to measure this as how many seconds per feet? How do we measure speed? Feet per second or seconds per feet? Feet per second. So we want to find the change in feet over the change in seconds. That's how you, remember I said, time should always be where? The bottom, right? I shouldn't say always, 99% of the time. So if you have time, like seconds, minutes, hours, days, put that on the bottom. So we're going to find the change in the feet of the water and then the change in seconds. Okay? So think of the depth, the feet as y, and the seconds as x. So let's say 10 seconds after he got into the water, he was 30 feet below the surface. And then 40 seconds after he got in the water, he was 100 feet from the surface. So you can organize it as ordered pairs if it helps. All right, here we go. Change in feet. 100 minus 30 over change in seconds. 40 seconds, take away 10 seconds. All right, what's 100 minus 30? 70 over what's 40 minus 10? So guys, right now, that is your rate of change. He is swimming at a rate of 70 feet per every 30 seconds. But I don't want that. I want to know how many feet is he swimming per every 1 second. So divide them. It's going to be ugly. It's a decimal. We're going to round to 1 decimal place. And then we'll put it over 1. So guys, anybody know what 70 divided by 30 is? 2.3 repeating, right? So let's just say 2.3. So we're going to say 2.3 over 1. So he is swimming 2.3 what? Feet per every 1 second. Exactly. That is his rate of change. What's up? Yes.
Like, let's say for like this scenario, like for the first couple of seconds, you're going faster than the last couple of seconds.
Well, we're saying an average rate means taking into consideration that he may be fast forever. On average, based off of this data, he's swimming about 2.3 feet per second. Which is usually why a lot of times these problems will say, assume he swims at a constant rate. They'll even put that in there, okay? All right, I'm gonna do this one, and then I'll have you guys try the last one. The only reason I wanna do this one is, guys, when you do a rate of change, normally they have to give you 2 things that are changing, right? This one was feet and seconds, and they have to give you 2 pieces of information about it. They gave us 10 seconds and 30 feet, they gave us 40 seconds and 100 feet, okay. This one is a little bit different, because watch how it's said. It says, over the last 50 years, the average temperature has increased 2.5 degrees worldwide. What is the rate of change in the worldwide temperature per year? Guys, read that again. They asked for what? Per what? Temperature per year. So we should be changing or comparing the temperature per the year. That's how they want this set up. So be very, very happy when they tell you how they want the rate measured. They want it in temperature per year. Well, guys, did they give you 2 different temperatures? Did they give you 2 different years? No, they're just flat out telling you that the rate of change right now is it is changing 2.5 degrees every how many years? How many? 50. So right now we know this. It is changing 2.5 degrees every 50 years. That's what we know. So guys, they didn't give us another set of information to compare this to. All they want to know is if this what it's doing every 50 years, then what is it doing per every 1 year? So all we have to do is reduce this. Take this, divide it, put it over 1 so we can see what the temperature change per year is. Guys, it's going to be small. It's only changing 2.5 degrees every 50 years. So the amount that it's changing every 1 year is extremely small. So what's 2.5 divided by 50? 0.05 degrees over 1 year. So guys, that means at this rate, it's only increasing 0.05 degrees per every 1 year. So that one was different because they basically gave you the rate of change. All you had to do was convert it into his unit rate. What's he doing every 1 year? All right, let's read the last one and then you guys are going to do it. It says, after 30 baseball games, Mike Trout had 25 hits. If after 100 games, he had 80 hits, what is his average number of hits per game? Guys, read that again, right there. What's it say? What per game? Hits per game. So who's on top? Hits. Who's on bottom? You guys, you better be thankful when they give you that. They are giving you the rate at which they want it measured. They want it in hits per game. And I will tell you right now, you're going to think your answer is really, really weird. But it's not wrong. So if you get a weird number, you're not wrong. Yes? Kyler, you you okay, sweetie?
Yeah, I'm good.
Okay.
Except
Go ahead.
yesterday I have a question.
Okay, let me finish this, okay? It's different. Don't think you did anything wrong. Again, I'd just like you to see it as the ordered pair, if that helps. Everybody on the right track at least, you think? Okay, as far as change in hits, from 85 to 25, what was his change in hits? 55, beautiful, over. The change in games is 70. All right, now guys, pause. This is where you gotta look at it. They're saying right now his average hits per game is 55 hits per every 70 games. Well, guys, hold the phone. How many games has he played technically? 70. If he got 1 hit per game, how many hits should he have? 70. Does he have less or more than 70 hits? Less, which means he's not even averaging a whole hit every single game because he has less hits than the total number of games he's played. So it would make sense that if you got a decimal, you're okay. Because if he was going to have more than 1 hit per game, he'd have to at least have 70 or more change in hits. So if this is what he's doing every 70 games, divide it, give me 2 decimal places. What's 55 divided by 70? 0.79 over 1. So guys, he's averaging 0.79 hits per every 1 game. So I know it seems weird, like, wait, what? But he's not even averaging an entire hit every single game because he has less hits than the number of games he's played in. Yes?
What if you longer side put 0.8?
No, I didn't specify how many decimals to keep. Okay, all right, so guys, that's how we do slope word problems. Do you guys remember these from Algebra 1? A little bit, right? Okay. So what I did is, because I changed my plan, I'm gonna come in and just start graphing on Monday. So I had just originally made a homework for you, just practicing slope using 2 points. So I'm gonna leave that. That I didn't make due until Sunday night. This is, I know it's Friday. You're doing stuff tonight, that's fine. You have 8 slope questions, none of which are word problems, that are due Sunday night. On Monday, I'm gonna give you a review. That'll have some word problems on it, and then Tuesday we'll quit. Okay? All right. And then don't forget, yesterday's homework is due tonight if you haven't done it yet.